Swayam Prabha. Digital India. Educated India.
Hello student, we are on the same module, module 8 and transformation, chemical transformation we were discussing, and in the previous two lectures I talked about the major environmental issue from the incineration or combustion process. One was flue gas treatment, that is the one of the major environmental issue, and second one is a solid residue is getting produced after incineration process. So, today we are going to talk about flue gas characteristics and followed by treatment one. So, first we will go for combustion products. What are the combustion products are getting produced during the incineration process. So, at very high temperature and obviously we are putting huge amount of oxygen also or air for the complete burnout of the dry waste, that will convert entire the material will convert into the chemical stable product under oxidation condition, okay, in the presence of air or oxygen. And these products either enter in the gas phase, the maximum will go into the gas phase, almost 80% goes to the gas phase, and remaining will get remain as solid residue in the fuel bed. Okay. So, this is what I was talking about, two major issue. One, when the entire material is converting into the gas phase, other is the solid phase or solid residue. So, here you see that there are different kind of products are coming out from the incineration process or combustion process. The first one is the mineral material, another is the carbon, hydrogen, sulfur, nitrogen, halogens and volatile heavy metal. This is one of the very important one because normally we found that the metal won't get possible in the air, but as we know that in the incineration process temperature goes up to 1100 degree centigrade. So, in that case some of the metals is getting also volatile and that will come up into the flue gas. Now, first is the mineral material. So, what could be the mineral material? So, there could be this kind of metal like iron, manganese, nickel and their compounds, and I think this mostly this will come up in the bottom ash, okay, that solid residue, okay, or slag we can say, that is a end of grate. I think you saw in the previous lecture in the line diagram, and trace of product of incomplete combustion is also found into the bottom ash. So, these mineral materials is normally found as in the solid phase, and that normally we called as a bottom ash or slag. Now, next is the second one, carbon, hydrogen, sulfur and nitrogen. So, stable oxidation product of all carbon compound, that is convert into CO2 in the gas phase, hydrogen convert to the H2O, that will be also in the gas phase, sulfur is converted into SO2 and solid sulphate. I think both the products will gaseous and also come up in the solid form also, and that is a solid sulphate. Nitrogen partially convert into NO, that is one of the most polluted gas. This NO is oxidized into NO2 and N2O. This is also very problematic gas. Depending on the operation mode, the more or less particulate matter, this PM also leaves the furnace, and that normally we called as a fly ash, okay. That is also coming into the solid residue. And the uncompleted combustion of carbon lead to formation of CO, TOC and PAH, that is another problematic particles and soot particles also are getting produced. These soot particles are known to be a source of toxic, low volatile, halogenate organic micropollutants, especially P, C, D, D and F. This we will discuss in the detail, that is normally called as a dioxin and furans. Now, the halogens. So, there are different type of halogens also is getting produced like chlorine, bromine and fluorine, and these mostly these halogens is coming into the solid residue. Now, the finally is the volatile heavy metals. So, these many metals are evaporated as chlorine in the furnace, okay, in the form of chlorine, and more than 80% of content of mercury and cadmium in the waste leaves in the combustion chamber in the flue gas. You see that more than 80% of mercury and cadmium that is coming into the flue gas, 30 to 50% of zinc, arsenic and lead, this is also evaporated in the combustion chamber, transferred to the raw gas, that is also coming into the flue gas. And especially in the boiler outlet temperature of 180 to 200 degree centigrade, the volatile heavy metal species except mercury and its compound are bound to particulate matter and are removed along with the dust in boiler and filter ashes. Okay. So, these kind of metals also, volatile metal also is getting produced, and mostly these metals are coming into the flue gas and need to be treated followed. Now, the flue gas. So, this lecture I think we will mostly talk on to the flue gas characteristics and followed by their treatment. So, about 80% of waste is transferred into the flue gas during the waste incineration process, as I told. And the problematic compounds in the flue gas, these are the major compounds in the flue gas. First is the dust or particles, acidic gases like HCl, HF, SO2, NOx, nitrogen compounds, heavy metals, and these are the organic compounds like dioxins and furans, that we can call as a PC, DD and F. So, flue gas must be extensively cleaned before being released to the atmosphere through the stack of the plant. See here, so I am saying is a extensively cleaned. So, sometimes it is also found in some of the literature, the cost of treatment of flue gas is more compared to the furnace or combustion process. So, here you can understand that we need have very extensive cleaning facility of flue gas. Now, here I compared the concentration, what kind of normally concentrations are coming during the combustion process, different compounds along with the mass flow, and here is the European Union standard, American standard, and recently India also come up with their standards. So, you see here the dust or particles which I was talking about, the major concentration is the dust, that is coming around 1000 to 5000 milligram per meter cube of flue gas, and standards are only 10, like in the European standards, American standards are 54 and India standard is 50. So, similarly like for NO2 the standard is 400, okay, and like dioxin and furans that is 0.1 nanogram per meter cube, that is the standard. So, now I think these kind of concentration has to treat, so that we can get it these under these standards, okay, especially this is for India. But I think initially only the European Union they come up with the standardization, followed by America, they come up with the standards of the flue gas. Now, India also has come up with proper standards of treatment. Now, we will talk about the flue gas cleaning system. So, normally once from furnace flue gas is produced, that will go to the flue gas cleaning system. Okay, so, flue gas cleaning system required to reduce the concentration of specific pollutant to concentration well below the respective air emission limit, okay, which we saw in the previous slide. And there are 4 major pollutants. First is the which we are going to talk into this lecture, the dust or particle, acid gas, that is HCl or HF gases come out in the flue gas, dioxins and furans, and finally nitrogen compounds. But before that, I think here you see in this line diagram one very important unit of this entire flue gas cleaning system is a ID fan. Okay. This we are going to first we will discuss in one slide, then we will go for one by one pollutant treatment. So, these ID fans called induced draught fan. See here see is the draught fan, you see in the previous slide it is put it in the last. So, now see whatever gas is produced from the furnace, how that gas will go to the treatment system, or how we can maintain the velocity, whatever velocity is required through the cleaning system, and again that gas has to go to the stack. So, this management is entire by the ID fans. So, ID fan is in the end of this treatment system. So, that the whatever the flue gas is produced from the furnace, that will go through the flue gas treatment systems or facilities. So, this is the key component in the flue gas treatment system. You see here, this is the one of the diagram you can see of ID fan. This ensures the transport of the flue gas from the furnace through all the process step of the flue gas treatment plant to the stack. This is what I was talking, this is specially ensure the transport of flue gases. Located in the back end of the process train, the ID fan also ensure that no pollutant flue gas except from the process equipment. This is one of the very important point. It is possible because the temperature of this flue gas in the initial phase goes to 700 to 800 degree centigrade, and it is possible that it will accept from the that particular line. So, this ID fan is located in the end of the entire process. So, that this flue gas should not be accept from the process equipments. So, flue gas transport is quite demanding in the term of power consumption, and the ID fan is the largest single power consumer in the entire waste incineration plant. This is what I was talking about, the cost of treatment itself sometimes is very high compared to the installation of entire incineration plant. Why? Because the cost of these fans also is sometimes is very high and high power consumption. So, power consumption means obviously the maintenance cost is also very high of the incineration plant. So, now first for one by one pollutants will go. The first pollutant is the dust. So, how the dust removal? So, there are different kind of treatment facilities available for the dust removal. The first is the cyclone. So, cyclone uses inertial impaction of the fly ash separation, like you see here, this is one of the line diagram of the cyclone. So, the flue gas is getting like way is passing through this particular vertical unit. So, the gas enters a cylinder chamber tangentially at the high velocity that force into a cylindrical path. Okay, very high velocity is entering into the cylinder, and the centrifugal force acting on the particle causes them to collide with the wall, where they impinge and settle down into a discharge hopper. So, whatever particle is getting impinged onto the wall, and then finally is deposited into the discharge hopper. The clear gas is extracted through a central tube, okay, and removal efficiency is 50 to 90%, and this particular treatment unit can operate at temperature up to 450 degree centigrade. That is one of the major benefit of this treatment system. So, and whatever the gas is produced from the furnace, the temperature obviously goes up to 800 degree centigrade. So, directly that gas can go to the cyclone. So, this is industrial cyclone, you see here, this is also in the similar way the cyclone. This is a industrial cyclone dust removal in India. Now, next unit is the electrostatic precipitator. This is one of the oldest treatment unit for removal of dust or particle. The small size particle, fine particle also can be easily removed from the electrostatic precipitator. Here in the ESP, the electrical field is established between the grounded metal plates and central wire, which are negatively charged by rectified AC power. So, there will be a two plates like this will be a two metal plate, and inside there will be a wires, and these wires high voltage wire for corona discharge. So, that will be having negative charge, and the flue gas pass the alloys between the plates at the low velocity, that is 0.5 to 1.5 meter per second. This is the raw gas from the alloys of the two plate, and the central wire, these are the wires, central wires. The flue gas particles are ionized by the corona discharge and start to move or migrate along the line of the electrical field until they impinge upon the plate. Okay. So, mostly these particles are the positive charge. So, and these corona wires will have negative charges. So, whatever particle will directly impinge onto the plate, and finally, the plates are getting cleaned, and that entire particles or solids are getting collected into the discharge chamber. At certain time, the deposited particle are removed from the plate by wrapping or mechanical vibration of the plate and collected into the discharge hopper. So, removal efficiency is very high, 95 to 99.5%, and the operated temperature is up to 400 degree centigrade. Now, this is one of the few photographs, few picture of the electrostatic precipitators. So, these are the wires. Okay. This is another installation of electrostatic precipitator plant. This is in India. Now, the fabric filter, this is another technology or another treatment technology is available to remove the particles or dust. The raw gas passes through the fabric bags, which are supported by the metal cage. So, this is the fabric bags. Okay. And gas flow in commonly from the outside to the inside. So, from outside to insides, and finally, from this the clean gas will come out. The dust stays on the outside of the bag and periodically removed by air pulses opposite to the filtration direction. So, time to time the solids got settled down, that will get removed out. And removal efficiency is also very good, I think 99 to 99.5%. The problem only the operating temperature should not be more than 250 degree centigrade, because it is a cloth bags, okay, or fabric bags. So, obviously, we can't put it the higher temperature gas into those fabric bags. This is fabric bag plants in Australia. Now, the last unit is a Venturi scrubber. This is the well known technology, normally is available onto the incineration plants, and especially the incineration plant for medical waste. I think this technology is available in India also. So you can anywhere medical based initiation plants available, this technology you can see very easily. The flue gas is accelerated at to high velocity by passing a funnel with a reduced cross sectional area, that is the venturi, and also water is injected and atomized. So, here this is the venturi throat. Okay. So, raw gas is entering. Now, here the scrubbing liquid water is getting deposited onto the raw gases, and because of that the particle will mix with the water and that will come out into the slurry form, and remaining clean gas is getting come out, and that is also one cyclone is provided, venturi throat followed by one cyclone, and from the cyclone clean gas will come out. The water aerosol caught by the flue gas pick up the large fraction of the ash particles, and the water droplets are subsequently removed in the cyclonic separator. If HCl is present, I think this is the acid gases is present, it dissolve in the water aerosols and reduce its pH, creating corrosive condition, needs treatment prior to discharge or reuse. Now, here removal efficiency is 90 to 99%, and this also we can run at not very high temperature, but temperature goes around 400-500 degree temperature also we can easily operate this venturi scrubber. This is one of the unit of venturi scrubber. Now, the next pollutant is acid gas. The acid gas can be removed by the number of technology which can be categorized as wet or dry system. So, first we will go for wet system. The wet scrubbing is normally applied after the fly ash has been removed, typically in an ESP. So, you see that wet system is applied normally once the fly ash is getting removed out, then we can go for wet scrubbing facility. So, this is the wet scrubbing facility. So, this is the water is getting sprayed and the flue gas from the down, flue gas is entering into the cylinder, and finally, clean gas is coming out. Principle is absorption of gaseous compound into a liquid. So, their efficiency depends on the available surface area of the liquid, which controls the mass transfer from the gas into a liquid phase. So, it has a two stage installation with a initial acidic scrubber to remove HCl and HF, followed by slightly acidic or neutral alkaline scrubber to remove SO2. Both the acid gases could be removed. First is the acidic scrubber followed by alkaline scrubber. But problem is this wet scrubber is often operated with discharge of liquid effluents. So, lot of slurry is getting produced, and this liquid effluent goes to 100 to 300 liter per ton of waste combusted or incinerated, and required neutralization of neutral pH and an efficiency removal of any heavy metal or either other toxic contaminants. So, if you are planning for wet scrubbing treatment facility, also required one wastewater treatment facility to treat that liquid effluent. So, this is one of the scrubber. This is package bed wet scrubber. Now, for dry system, normally we injected two chemical compounds like calcium hydroxide and sodium bicarbonate NaHCO3 are injected into the flue gas for neutralization of acidic gas compounds. See, in the dry process the agent is injected as an dry powder, maybe together with water, while in the semi dry system the agent is injected as an slurry that dries in the flue gas. So, this dry system, how it will remove the HCl, and if you are adding calcium hydroxide, it will produce calcium chloride plus H2O. So, finally, this HCl, this is the acid gas in the flue gas is treated by adding few chemical compound. So, dry system sometimes is mixed with the Venturi scrubber. So, we see that in the Venturi scrubber water is injected into the throat. So, in that case in the water if you are mixing these chemical compounds along with the water. So, not only the dust will get also removed, also the acids available in the gases that will also get removed under the Venturi scrubber system itself. Now, the dioxins and furans that normally called PCDD and F. What is PCDD? That polychlorinated dibenzo P dioxin and dibenzofurans that normally called PCDD and F, or simply we can call it a dioxin and furans are already present in the MSW, but they are almost totally destroyed in the combustion chamber. So, at the temperature reach up to 800, 850 or 1000 degree temperature, all the dioxins and furans will get destroyed completely. But when the temperature is getting lower down of the flue gas, again the new formation of dioxins and furans could possible. So, in the boiler the temperature down to 200 degree centigrade, a new formation take place, means normally temperature less than 400 degree centigrade, again these dioxin and furans are getting produced into the flue gas. The gaseous dioxin furans can be adsorbed onto the activated. This is the only technology available now for dioxin removal, that is activated carbon in the bed filter or a carbon injection system in combination with Baghouse filter or fabric filter. So, this could be adsorbed onto the carbon bed filter. So, simple adsorption process followed by fabric filter treatment facility. By that way we can remove or we can treat the flue gas for the dioxins. So, such system this kind of treatment system often found in the polishing stage at the rear end of the standard flue gas cleaning system are normally called as an polish filter. So, these units will be the last unit of the entire flue gas treatment system. So, normally called as a polish filter. Now, the NOx nitrogen compounds. The NOx is common term is a nitrogen oxide and nitrogen dioxide. This could be a two form. In waste incineration, typically more than 95% of total NOx in the flue gas is present as NO, that is the problematic one. If the combustion temperature drops below 850 degree centigrade, an increasing fraction of NOx is present as N2O, and problem with this N2O is a extremely high greenhouse gas potential. If you compare with CO2 is 1. So, this N2O is the greenhouse gas potential is 310. Now, see that if the temperature will drop than 850 degree centigrade, then the entire nitrogen will get converted into the N2O. So, this is what the idea behind the standardization of the temperature. So, you saw in the European Union also and for Indian standard also, in the first furnace the temperature should be more than 850 degree centigrade, just because for nitrogen compounds. So, there are two kind of removals treatment facilities are available. One is the selective non-catalytic reduction SNCR and selective catalytic reduction SCR. So, selective non-catalytic reduction is by injecting ammonia NH3 or NH2 containing compounds into a secondary combustion chamber of the furnace for reduction of NOx to N2. Okay. So, this is very easy process, but I think these methods non catalytic reduction we can put it into the secondary combustion chamber, where these combustion gases again is getting combusted. So, minor quantity of N2O are also formed in the non catalytic reduction, and this is what you can see the NO, because maximum percentage is NO. Once it is treated with the NH2 containing compound, so it will convert into the N2 gas. Or suppose if you are one non catalytic compounds, if you put it like ammonia, then also the very easy process to convert nitrogen compounds into N2 gas. And for selective catalytic reduction is mostly common catalyst is V2O5 stabilized in TiO2. So, this is very costly process for using of catalytic reduction. So, is I think mostly cases we will find non catalytic reduction process is only is using for the treatment of flue gas nitrogen compounds. Now, finally, a stack, once the entire these all pollutants are get removed from the flue gas, we will find the stack also known as flue gas stack. Smoke stack, chimney stack is a type of chimney, a vertical pipe channel or similar structure through which combustion product gases, flue gases are exhausted to the atmosphere. So, this is one of the photograph in the USA. So, what is the standardization? So, as per our Indian Municipal Solid Waste Management Manual, so minimum stack height should be 30 meter above the ground. So, this is one of very important standard. See why this much height is required, because obviously we treated this flue gas for different pollutants, but still the some concentrations of some kind of pollutants will be always there. So, it is good to have the stack height more, so that the local residential people should not be create any, for them there should not be any issue, and should be attached with necessary monitoring facility, okay, required for monitoring of general parameter as notified under the Environmental Protection Act, that already emission standards are given. So, you see here somewhere the sampling is done onto the stack. So, I think recently also pollution control board, whether it is a state or central pollution control board, they used to collect the sample from this stack and will get analyzed in the laboratory. But now, I think many state pollution control board, they will have online monitoring system. So, they will put it onto the stack for the online monitoring system, and by sitting in the office itself, they will come to know what kind of characteristics of flue gas is getting dispersed into the atmosphere after flue gas treatment facilities. So, here we will finish the flue gas treatment facility. Now, I think the another one more important environmental issue is the solid residues. We do not have much literature onto the solid residues, but I think I will try a few slides to show about, because already some standards are given, what kind of ash should be produced and how it has to be treated to get the particular standards, and some treatments also available. That treatment is very difficult. We will see in the next lecture. So, thank you for today's lecture.